So the operating circuit voltage relates to the capacitors in as much that you always have a UF and then the voltage rating. So the voltage rating relates to the operating circuit voltage. So we learned that the supply voltage goes into the transformer, and then out of the secondary you'll get whatever amount of voltage is required to operate the bulb. So like this bulb here, it operates on 300 volts. So it doesn't matter if you put 120 in it or 480 into the transformer. And we're not really going to talk about ballast anymore. We're going to talk about just transformers, capacitors, bulbs, because it takes all three of them to make a ballast. Actually, the capacitor is more the ballast than the transformer. Transformer just changes supply voltage into whatever the voltage is that's required to operate the bulb. So operating circuit voltage is 300. In any electrical equation, you're going to take 300 times 120% to be on the safe side, which that equals about 360, and a nominal voltage for those capacitors is 400. You can find some of them in 360 volts. So for this bulb here, which is a 250, it would take a 15 UF 400 volt rated. So it doesn't have anything to do with what you feed the fixture with. It's what the transformer changes, and that's why we got into that part of it. And it's pretty important, but not as important as the UF, because the UF is the part where I told you it was current limiting. So that's the restriction part, where different values, and they usually go from lower value to upper value, deliver lower, less power, upper, more power. So for example, this particular bulb, the 250 watt metal halide, uses a 15 UF. And if this was a 400 watt metal halide bulb, it would use a 24 UF, along with a 1000 watt bulb uses a 24 UF. They just use more voltage rated capacitor because it's got more material in it, so that the in conjunction with the voltage and the UF, more voltage but the same UF delivers more power, because now we're getting into the 1000 watt metal halide operates on 400 volts. So that takes a 480 volt rated capacitor. Now the UF for, let's just say, and they're not as common, a 1500 watt bulb is 32 UF. 32 UF at 525 volts. So it even has more voltage driving it than the 400 for the 1000. It's up like around 475 or something like that. So a bigger microfarad and more voltage. So that kind of gives you an idea of why you want to make sure that your UF is very, very close, because that's your power range, and you don't want to overdrive your bulb. It will make it brighter and it won't last as long. You don't want to underdrive your bulb, because you won't get the light out of it. And it's all about bulb efficiency. So if your bulb's running efficient, it's going to last a lot longer. And that's the whole key to the capacitor, is to keep that bulb running at 100% efficiency. And that's what a capacitor does, is correct power factor, and which is keeping the voltage constant and also keeping, restricting the amount of power that those bulbs can run on, so it's efficient. So capacitance is all in electrical situations is about efficiency.